Hello friends, welcome to today's session. In today's session, we'll be having a discussion over the important topic from the thermodynamics, that is nothing but the first law of thermodynamics. Okay, so let us start our discussion by the topic first law of thermodynamics. First law of thermodynamics. Actually, this first law of thermodynamics, which it was proposed before the zeroth law of thermodynamics. In our earlier session, we have discussed what is zeroth law of thermodynamics, and we have discussed the concept of thermal equilibrium. If two bodies are in contact, if first body is in thermal equilibrium with the third body is in thermal equilibrium with the second body, and if A and B are not in thermal equilibrium, or they are separated, isolated from each other, though they are not in thermal, they are isolated from each other by using the equilibrium between first and second, or second and third body will be having a thermal equilibrium between first and second body, that we had seen in the zeroth law of thermodynamics. Now in today's session, what we will be discussing, that is a first law of thermodynamics. For to discuss the first law of thermodynamics, what we will do, what we will be considering one system. For example, let us consider this container is there, which is fitted with this piston. Okay, let us say this is a container which is fitted with this piston. So let us say this is a piston. Okay, and this container, it is having gas enclosed in it. Let us say this is the gas which is enclosed in this system. Okay, now what first law of thermodynamics tells us that, suppose the amount of heat is given to the system. Let us say dq is the amount of heat it is given to this system. So what will happen as we provide the heat to this gas? So let us consider this container is having certain amount of gas, okay, which is having this, let us say, initial volume and pressure. Let us say it is having pressure P, volume V, and temperature T is the parameters which are there for the specification of this state of the system. As we provide some internal heat to this one, as we provide the heat to this system, what happens is that its volume increases, and its temperature also increases. Okay, and that formulation, it was proposed in the form of first law of thermodynamics, which is nothing but the actually the extension of a first law of thermodynamics. It is an extension of law of conservation of energy. What it tells us that the amount of heat given to the system, it is used for two purposes. The first purpose is to increase its internal energy and to perform some work done. The amount of heat given to the system, it is used for two purposes. One is to increase its internal energy, to change its internal energy, and to perform some external work. Okay, so that is the mathematical expression for the first law of thermodynamics. From this one, we can prepare some theoretical statement for the first law of thermodynamics. So first of all, we will note it down. What statement first law of thermodynamics tells us. Okay, first law of thermodynamics, it states that the amount of heat given to the system, is used, or is equal to the algebraic sum of, or is equal to the sum of change in internal energy, and some external work done. Okay, so from this one we can see what happens to this container. See the amount of heat given to the system. So if I heat this gas which is inside this container, so what will happen due to that one? Its temperature will increase, and we know that temperature is a internal energy is a function of temperature. So as temperature increases, internal energy increases. Okay, so its internal energy will increase, so du will increase, and external work done. How this external work can be calculated? See, suppose the initial volume of this one, let us say P1, V1, T1 is the pressure, volume and temperature of this gas. So if I heat this one, let us say P2, V2 and T2 will be the temperature, volume and temperature of this system after providing a certain amount of it. So if you consider over here, its volume is increasing from V1 to V2. Its volume is increasing from V1 to V2. So if I am saying that the gas is expanding, the gas is expanding, in that case, your change in volume, it will be what? V2 minus V1. So if it is an expansion, then this quantity will be greater than 0. It will be a positive quantity. And we know the work done, which is a product of force into displacement, and this piston is displacing with a certain distance. So, and we know that pressure is nothing but force upon area. Force upon area. From this one, if I calculate pressure, force, then it will be pressure into area. So if I consider A is the area of this piston, and let us say from V1 to V2, let us say this piston is moving from this point to this point. Suppose it is going up to this point. Okay, so this will be the position initial. This was the volume V1 and this is the volume V2. Okay, so let us say that this is the distance which is covered by this piston. Then my work done, it will be force into displacement, which is F into dx. So whatever the force, it will be exerted by this gas on this piston, and we have calculated that force is nothing but pressure into area. So, and into displacement, that is dx. So area into displacement, if I say that A is the area of this one and this is the displacement, it is a dx. So it is the area multiplied by the height. It is nothing but the volume of this region. And what is this, that volume? That is nothing but the dV, change in volume. So it is now work done, it is dW is equal to P into dV. So this first law of thermodynamics, you can express it in this form as well. Your dQ is equal to du plus dW. We can rewrite this as an P into change in volume, that is dV. So this is nothing but the mathematical statement of a first law of thermodynamics, in which the first quantity represents a internal energy, second quantity represents a work done. Okay, so that is the first law of thermodynamics. Now what we will be doing, we will be considering a different kinds of a thermodynamic processes. Basically there will be 4 to 5 thermodynamic processes are there, which are very important as far as the engine working of an engine is considered. Okay, so those thermodynamic processes we will discuss, and we will see how this first law of thermodynamics behave in those type of thermodynamic processes. So let us start with the next topic, that is nothing but the thermodynamic processes, different thermodynamic processes. Okay, so first thermodynamic process it is there, that is called as a isothermal process. First for the thermodynamic process it is there, that is nothing but the isothermal process. Isothermal process. Now, what is isothermal? It is derived from the two words, that is iso. Iso means same and thermal means temperature. So within the process, if the temperature is remaining same or if some quantity is remaining same, means it is constant quantity. So in isothermal process, temperature of the system remains constant. So we can define this isothermal process. The thermodynamic process, the thermodynamic process, thermodynamic process in which temperature of the system remains constant. Temperature of the system remains constant remains constant is called isothermal process. Is called isothermal process. Is called isothermal process. Okay, so that is the definition of an isothermal process. So in this case, our temperature is constant. Okay, temperature is constant. So just in the previous section we have considered that internal energy. What? Internal energy. It is a function of internal energy is a function of temperature. Now in this case, as the temperature is constant, as in this case temperature is constant, as temperature is constant, so internal energy, which is a function of temperature, so that will be also constant. And we know that if something is remaining constant, then the change in that quantity, it will remain constant. The change in that quantity, it will be zero. So from first law of thermodynamics, from first law of thermodynamics, we know the mathematical statement dq is equal to, what is the first law of thermodynamics? du plus dw. du plus dw, and this we can rewrite in this fashion: dq is equal to du plus dw. We have considered that is P into dV. So whatever amount of heat is given, it will be utilized in for two purposes. First one is to increase the internal energy and to do the some external work done. So for isothermal process, as the temperature is constant, so this first term, which is du, it will be zero. So from this one I can rewrite dq is equal to dw. dq is equal to dw, as since du is equal to 0. So from this one we can note it down. In isothermal process, what happens, as the temperature is constant, so internal energy is 0. Change in internal energy is 0, and change in internal energy is 0. So whatever the amount of heat is provided to the system, it will be utilized only for the work done. That is the reason why the maximum work done, it will be gained in case of an isothermal process. So this is nothing but the maximum work done. Okay, we will be calculating this maximum work done in the next our next session. Okay, so from this one, in isothermal process, the amount of heat given to the system, is totally converted into work done. Okay, so that is why the reason we are getting an maximum work done in this case. Okay, so that is about the first law of thermodynamics for the isothermal process. Okay, now we will move to the next thermodynamics process, that is nothing but that is called as adiabatic process. Okay, now we will consider the adiabatic process. Next thermodynamic cycle, that is adiabatic process. Now, what is this adiabatic process? Adiabatic process is a process in which the system neither take heat from the surrounding or it nor gives the heat to the surrounding. Okay, so total heat given to the system or taken from the system, it is 0. So in this case, what we are assuming is that no net heat content change in the net heat given to the system or taken from the system, that will be 0. The thermodynamic process in which neither take hit nor give hit to the surrounding is called adiabatic process. Is called adiabatic process. Is called adiabatic process. So that is for an adiabatic process, the net amount of heat that will be 0. So that is for isothermal process. From first law of thermodynamics, we know the mathematical statement. From first law of thermodynamics, what we have derived is dq is equal to du plus dw. dq is equal to du plus dw. That is a mathematical statement of the first law of thermodynamics. As for the adiabatic process, dq is equal to 0. If I substitute it in this equation, okay, dq is equal to du plus dw. So dq is equal to du plus dw. So from this one I can rewrite dw is equal to, if I transfer this du from this side to this side, it is plus, on this side it will becomes minus. So dw is equal to minus du, means, so whatever the amount of work done we will be getting in case of an adiabatic process, that will be due to the decrease in the internal energy, because here we are getting the negative sign. So change in internal energy will be negative. So final internal energy minus initial internal energy, it is coming out to be negative. So it means that the temperature of the system is decreasing. The examples of these processes are, suddenly if you puncture the balloon, or suddenly a tire of a vehicle burst, it is an adiabatic process, because in this case it is not given to taken from the system, surrounding, but suddenly volume decreases, or expansion happens. So in that case, the work done which you will be getting, it is due to the expense of the internal energy. Due to that one, the temperature of the system falls, means the internal energy decreases. So you can write down from the adiabatic process, the amount of work done in adiabatic process, it is due to the expense of the internal energy. Okay, so that is an adiabatic process. We will consider now the third important process. It is there, that is nothing but isobaric process. Third process it is there, isobaric process. Third process, that is isobaric process. Okay, isobaric process. Now what happens in case of an isobaric process? If the thermodynamic change, it is occurring at a constant pressure, such a kind of process is called as an isobaric process. So we'll note it down, the thermodynamic process, the thermodynamic process in which the thermodynamic process in which the pressure of the system remains constant. Pressure of the system remains constant is called, pressure of the system remains constant is called isobaric process. Is called isobaric process. Is called isobaric process. Okay, so for an isobaric process, what we are having is pressure is equal to constant. Pressure is equal to constant. That is a simple limitation is there. Pressure during the system, it will be constant. Pressure during the process, it is constant. From first law of thermodynamics, we will consider what we get from the first law of thermodynamics. From first law of thermodynamics, what you can have is dq is equal to du plus dw. we know that this work done we can rewrite dq is equal to dq is equal to du plus work done we can rewrite this as an pdv. So if you consider from this expression, in this case pressure is remaining constant, so here the whatever the amount of heat is it is given, it will be used for the two purposes. One is for the to change its internal energy and to perform some amount of external work done. So in this case, the first law of thermodynamics, it is not showing any kind of change. If the process it is considered, it is isobaric process, and the last most important process it is there, that is called as an isochoric process. The last process which is of prime importance, that is isochoric process. So what is isochoric process? As in isobaric process, pressure remains constant. In case of isochoric process, volume remains constant. Okay, so we will first of all define this, what is isochoric process, and then we will try to calculate what significance we can calculate from the first law of thermodynamics. So what it is states that the thermodynamic process, the thermodynamic process, the thermodynamic process, the thermodynamic process in which the thermodynamic process in which the volume of the system, the volume of the system, the volume of the system remains constant, volume of the system remains constant, is called isochoric process, is called isochoric process, is called isochoric process. Okay, so for an isochoric process, volume remains constant, so V is equal to constant. For this isochoric process, volume remains constant. As volume is constant, okay, so what happens from the first law of thermodynamics? So from first law of thermodynamics, we know the statement of the first law of thermodynamics. What is first law of thermodynamics? dq is equal to what is that? du plus dw. dw is nothing but the p into dv. dw is nothing but p into dv. So whatever the amount of heat it is given, it will be used to increase the internal energy and to perform some external work. But as in this case, for an isochoric process, what do we have? As volume is constant, so change in volume it will be 0. So change in volume it will be 0. So as change in volume it will be 0. So in this case, dq is equal to, this will be du plus 0, because dv it is coming out to be 0. So from this one we can rewrite that the whatever the amount of heat it is given in case of isochoric process, it will be used only for to increase its internal energy. Okay, so in isochoric process we are not getting any kind of work done. Okay, we are just getting whatever the amount of heat it is provided, it will be used to only the increase its internal energy. Okay, so that is the significance of a first law of thermodynamics for an isochoric process. Okay, so basically in today's session what we have discussed is, we have discussed what is first law of thermodynamics, which states that the amount of heat given to the system, it is used for the two purposes. The first purpose is to increase its internal energy, and second one is to perform some external work. Okay, we have applied the first law of thermodynamics for the isothermal process. For isothermal process, temperature remains constant. As temperature is constant, so change in internal energy will be 0. So whatever the dq, this first law of thermodynamics which reduces to dq is equal to dw. So means in isothermal process we are getting a maximum work done. This maximum work done in an isothermal process we will be calculating in the our coming lecture. After that we had seen what is adiabatic process. In adiabatic process, the amount of heat given to the system or taken from the system, it is 0. So in that case we have what? dq is equal to 0, so dw is equal to minus du. So in case of an adiabatic process, the amount of heat as it is 0, so amount of work done we are getting, it is in the expense of internal energy, that it is there. So in temperature of the system falls, so the dW is equal to minus du. That work, kind of work done also we will be calculating in the coming lecture, that is the work done during an adiabatic process and work done during an isothermal process. And lastly, we have discussed what is isothermal process. In that case, pressure remains constant. In case of isochoric process, volume remains constant. So as pressure remains constant, there is no change in the first law of thermodynamics for the isobaric process. And for the isochoric process, the whatever the amount of heat it is provided, it is totally converted into internal energy. Okay, I hope you people have understood this session. Okay, we'll come with the new topic for the next session. Okay, thank you.